Okay, hi everyone. So today we're going to be talking about the next lab and the work that you're going to do in that lab. We're going to be introducing a robot to you, and you're going to be drawing that robot in the lab and drawing it, both sketching it and drawing it in MATLAB. So here we go. Here's what we're going to talk about here. The robot is right here. It's a two-axis robot. That means it has two motors on it. And the first motor is found here. And the second motor, so I'm highlighting it right there, the second motor is on top. It's this one right here. And the two are connected to each other with a servo axis. So this is motor number 1, and that's motor number 2. And basically, the way this works is that there are these two motors, and this one on the bottom allows the top one to turn like that, along that axis right there. And this second one allows this arm right here, this thing right here, to pivot up and down. So this one allows pivoting to happen up and down, and this bottom one right here allows it's called yawing. Okay, and actually this isn't pivoting, this is more like pitch. So it's yawing and pitching. So we've got these two motors on here, and they allow movement to happen. What we need to do right now is draw what this robot is in MATLAB, and we're going to sketch it first. So the first thing to do is we need to talk about dimensions. So the dimensions that we're talking about, roughly, if you take a ruler to these motors, you'll see that they're 4 centimeters by 2 centimeters by 3 centimeters, roughly. So they are this one's 3 centimeters high. This one is here, it's 2 centimeters across, and this right here is 4 centimeters deep. The top motor is pivoted, it's turned on its side, so that is 2 centimeters. That distance right there is, let me see, that is, I think that's 4. No, that's 3. That's 3 centimeters right there. And this distance right there is going to be the 4 centimeters. Like that. Okay? Now what we have to do is draw it on isometric paper. Here we go. So the isometric paper allows you to do these drawings, and you're kind of constrained by how these dots are. So in terms of the orientation of things, so we'll roughly approximate what this image here looks like, and you're going to want to do the same thing as well. So we have two objects. We have one on the bottom, one on the top. We'll start with the top one. So we're going to go like this. We're going to go 1 and 2. Okay, so that's 2 centimeters, like that, 1 and 2, and then we're going to go 3 across. 1, 2, and 3. 1, 2, and 3. Then we're going to go 4 deep. 1, 2, 3, and 4. And we're going to complete it. 1, 2, 3, and 4. 1, 2, and 3. 1 and 2. 1 and 2. 1, 2, 3, and 4. Okay, so this is 2 centimeters across there. This is going to be 4 centimeters across from there to there. And this is going to be 3 centimeters from there to there. Now we're going to make another one on the bottom as well. Now they're slightly offset from each other. One's a little bit raised off the other one. Don't worry about that for the isometric drawing right here. So the bottom motor is going to be 2 units across, 2 centimeters across, and we do it like this. So that's 2. Then we're going to go, let's see, we're going to go 4 deep. 1, 2, 3, and 4. Then we're going to go 3 high. 1, 2, and 3 like that. We're going to complete it like that, like that, like that, and like that. So this one is 3 high, 4, and 2. Now we haven't completed the rectangle here, or the box, so what we have to do is complete that in here. Oops. And there, whoops. There we go. So we've now completed those 2 boxes, and I can actually shade it just so you can see it a little bit better. So I'm going to make the top one blue. I'm going to make the bottom one green, just so you can see the difference between the two, like that. Okay, that's a rough approximation of what these 2 motors that make up the robot are. Okay, now the next thing that we're going to do is we are going to have to dimension out angles as well in order to make the MATLAB drawing. Okay, so we're going to switch over to that now. Okay, so next up, what we have to do is talk about the actual dimensions for this robot so that we can draw it in MATLAB as well. Okay, so we have to think of the 2 boxes as how we would draw it 3-dimensionally in MATLAB. So that bottom box, the bottom part of the robot that we've labeled as 1, here's how we're going to draw it. All right, let's get a nice thick line here. Okay, so it's going to look something like this. I'm going to draw it freehand. Okay, so it is going to be 3 units high. It's going to be 4 deep like that, and it's going to be 2 across like that. Now we're going to use the MATLAB coordinates. Okay, so the MATLAB coordinates are going to look like this. So Y, X, and Z, like this. Now this box is 4 deep, 3 high, and 2 across. We're going to start with a corner right here of, let me see, this would be 0, 0, and 0. Okay, so this is going to be, let me see, this is going to be point, this is going to be the first point right here. Then the second point is going to be, let's see, along X. It's going to be 2, 0, and 0. The point back here is going to be, let's see, 2, 4, and 0. Then this point right here is going to be 0, 4, and 0, like that. Now, we also have to have the points up here, 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 and here. Okay, so this one is going to be 0. This is going to be 0 as well, and this is going to be a height of 3. This right here is going to be 2, 0, and 3. This is going to be 2, 4, and 3. And this one here is going to be 0, 4, and 3. So we now have a box that works in MATLAB for that first motor that's down here. Okay, motor number 1 for the robot. All right, so next comes the hard part. We now have to draw that's the second box. The first one's easy to do in MATLAB. The second one we have to draw in MATLAB at an angle. And to do that, we need to think of the two boxes in this robot as from the top down. And then we're going to have to add in some angles and do some simple trigonometry, which turns out to be really complicated really fast. So here we go. So we're going to actually draw these two boxes slightly differently here. I'm going to change the color of the second box to purple, like this. Oops. All right. So we're going to do purple box on the top, blue box on the bottom. All right. So that first box we're going to draw like this. And we're going to go with a x, y coordinate system like this, y and x. Okay. So the first one is going to be, let me see, we're going to make that like this, 2 across, 4 high. That's the first one. Now the second one, we are going to pivot. All right, we're going to pivot it so that it's going to be like so. We're going to assume that the corner is coincident with the 0, 0, 0, 1, and I'm going to go like this. Like that. Okay, so it's going to be 4 across and 2 deep, like that. This angle right here, we're going to say, is going to be 30 degrees, like that. And so that's 30 degrees there, which means that this angle right here is also 30 degrees. And it means that this angle right here is going to be 60 degrees because there's a 90 degree right here. There, like that. That's 90 degrees right there. So 30 degrees, 60 degrees, and 30 degrees right there. Now, there are 4 points that we have to define like that. 1, 2, 3, and 4, like that. Okay, so here we go. For this purple box, what we have to do is define 4 points. Point number 1, 2, 3, and 4. And we're going to use SOHCAHTOA. Okay, so sine is the opposite of the hypotenuse. Cos is the adjacent and the hypotenuse. Okay, so this is the hypotenuse. That's the opposite. That's the adjacent, and that's the angle right there. Okay, so we're using the trick from trigonometry to pull this off. Okay, so point number 1 is going to be the same point as on there on the first box. So it's going to be at 0, x, 0, y, and it's going to be at a height of approximately, we're going to say approximately 3.5 centimeters above the bottom of the other point. Okay, so we're looking at raising that purple box about 3.5 centimeters off the base on that robot platform. Now for 2, what we have to do is we have to do the x coordinate first, and this is going to be, let's see, this point right here, number 2. And this is going to be 4 times cos, I'm going to use the wording from MATLAB, so cos d, and this is going to be 30 degrees right here. Okay, and then the y coordinate is going to be 4 times sine d of 30, and it's going to be at a height of 3.5 centimeters. The third point, this point right here, is going to be at 4 cos d of 30, and we're going to subtract, we're going to go back. Okay, so we're basically taking that first point 2, we're subtracting a little bit based on this triangle right in here. So we're going to go subtract, and the distance across there is 2, and that's going to be 2 sine actually, you know what? I've got the dimensions wrong there. That's not 2, that is 3. 3, because that's 3 right there. Okay, so that's 3 sine, that isn't 2, this is 3. Okay, so 3 of sine and 30 degrees. And then the y coordinate is going to be, let me see, I'm running out of space here. Hold on a sec. There we go. Okay, so it's, the y coordinate is going to be 4 sine d 30, and we're going to add to it plus 3 cos, oh, and that should have been a d right there, cos d of 30, and we're going to put this at a height of z of 3.5. The fourth point is that one right there, and we're actually going to go, it's going to be positive in terms of y, it's going to be negative in terms of x, because we're going to go back and across to the negative side of x, and we're dealing with an angle of 60 degrees right there. So here we're going to go minus 3 cos d of 60, like this. So there's a minus sign, 3 cos d 60, and then it's going to be 3 sine d of 60 for the y component, and we're going to be at a height of 3.5 centimeters like that. And so we now have 4 points to define that. So the next thing that we need to do is actually implement this in MATLAB. Okay, so next up we have to put this into MATLAB. So what I've got right here is a MATLAB illustration of the first box. Okay, so this is the motor that sits on the bottom of the robot. Okay, so motor number 1 right there. And we need to draw this. So how do we go about doing that? So I'm going to erase this. Here we go, hold on. Like that. I'm going to erase that and we're going to start over. Okay, so I want to make the bottom surface of that box. Then I'm going to do the top of the surface. Okay, so bottom and top. So we're going to do a patch, and we're going to make this patch blue. And it's going to have X, Y, and Z components to it. Now, the in terms of the parts that we've got, it's going, remember, it's a base that is 3 units high, but it's 2 across and it's 4 deep. Okay, so on our x-axis, we're going to have 4 points, 0, oops, like that, 0, 2, 2, and 0, along the bottom of that base right there. Then the y values are going to be 0, 0, 4, and 4. And then the z values are all going to be on the bottom plane. Okay, so they're all going to be at a height of 0. So 0, 0, 0, and 0. I'm going to run this. draw robot 2, save like that. And there we go. We have got a box. Now, unfortunately, it looks like it is a square, not a rectangle. And that's a weird thing that happens in MATLAB as it tries to adjust the axes to compensate for changing data and things like that. So we're going to, let me see, it's, hold on, it's axis equal, like that, yeah. So we're going to go axis equal, so that the x, y, and z axes will be of the same scale. I'm going to do that again. And there we go. So now it looks like an actual rectangle. Okay, now we can do a little cheating here. Okay, cheating in a good way. In order to make the top of my box, I'm going to simply take the bottom of my box and I'm going to adjust the height. The top of that box is 3 centimeters higher than the bottom of the box. So I'm going to go 3, 3, 3, and 3, like that. Save, Control S or Command S. Going to hit run and switch over. And there we have it. I have the bottom and top of my robot motor. So I can line it up sort of like what I see in the image right there. That's it right there. Okay, so now I've got to fill in the rest of the boxes. So let's put in a side patch. Like that. And let me see. So which patch do we want to do? Like that. This is going to be a side patch. Okay. Let's see. What could we do? What could we do? We're going to do all of the ones that have an x value of 2. Okay, so we're going to do sort of one plane where all the x values are equal to 2. And then the y values are going to be 0, 4, 4, and 0. And then the z values are going to be 0, 0, 3, and 3. Like that. And we filled in one of the sides right there. Okay. And I'm going to leave it up to you to do the other part as well. So we got to fill in that box. I'll leave it up to you to add in the rest of the values. Okay, so the last thing we're going to cover is how to wrap up the drawing of the 2 boxes in MATLAB. All right, so this refers to, I believe it's part 3 of the current lab. All right, so here on the screen, what you see is some text for drawing the robot. It's here in the editor window. And down below, what you can see is the robot that is being drawn. There's a motor on the top in red, and there's a motor on the bottom in cyan. Now, the way that this is drawn is that I've got some variables. Angle 1, this is equal to 12 degrees. I've got angle 2, which is equal to 90 minus that angle. And then I've got 2 colors, cyan and red, that are used to describe the colors of the 2 boxes. After that, what I've done is I set up my figure, so I call it figure 1. I have a command for resetting the figure every time I redraw it. It'll clear it and set it up nicely. After that, I want the proportions on the different axes to be equal so that a rectangle looks like a rectangle and not like a square. And this is a feature in MATLAB that's important to recognize. So that's in there as well. And then finally, there's this view, and you need to set this up like this, so the x view is -1, the y view is -1, and the z view is 1. This will line up the axes of the figure down here in this way, so it's looking sort of down at the robot from a particular angle, so that when the TA looks at your drawing, you'll have the drawing that the TA expects to see. So that's a really important thing to get the perspective. We can say that here. This is the viewing perspective. You can play around with it to see what it looks like from other directions, but really this is what the TA is looking for when they look at your images. After that, we are going to label the drawing. So I'm going to call it my robot. I'm going to have an x-axis, y-axis, and z-axis. And these are labeled on purpose. It helps you track where things are. Okay, so now what I'm going to do is I'm going to run this. And the image is shown right here. You can see this robot drawn right here. I'm going to change the angle. I'm going to make this, I don't know, 69.65 degrees. Okay, something like that. So I hit run and watch what happens to that red box right there. It changed angle. It rotated around this axis right here. We're assuming that the axis of the red box here lines up with the axis of the blue box as well. It's not quite right in terms of how the robot actually moves, but it makes the drawing of the two robot boxes much easier. So you assume that that corner of the robot itself on the top box is lined up with these corners right here on the bottom of the robot. Now, in order to make these drawings happen, okay, you need to label, or so you need to run the patch function in a particular way. Now, I'm only showing you a few of the patches because you need to program this yourself. On the bottom cyan box, here is the bottom surface patch. Okay, so you can see that basically I've got 4 points. It describes a rectangle. Okay, these are the 4 x points. So 0, 2, 2, and 0. Okay, so the 2 is 2 centimeters, 2 centimeters, and 0 centimeters. Then the y values are 0, 0, 4, and 4. And then the z values, because this is the bottom surface of that cyan box, the z values are all 0. And I'm using color 1, which was defined as cyan before. Now, the red box that's right here is defined a little bit differently. And that trig that I showed you in the previous part of the video, that's implemented here. And so what you can see is that all of the x values are defined here. So 0, and then this is 4, the hypotenuse. This is cosine in degrees, so cos d. Angle of 1, or angle 1 is the variable. Then after that, what we have is the next x point, and this is defined by 4 cos d angle 1 minus 3 times sine d of angle 1. So there's two triangles that are at play here. Okay, and then after that, the final point for x is minus 3. It's going the other direction. Okay, cos d angle 2. And remember, we defined angle 2 as being a variable that is dependent on angle 1. And there's a 90-degree relationship there. Remember that. Okay, then we have our y values defined as well. And then we have our z values defined. Okay, and this is the top patch of the top box. It's at 5.5 centimeters above. So it's basically it's 3.5 centimeters up and then another 2 centimeters on top of that. And then it's defined with color 2, which is red. Now the other thing I want to draw your attention to are these 3 dots right here, the ellipsis. And these tell MATLAB to go to a different line. You don't have to have them. If I got rid of them, then I'd erase it like this. Go back over here. And then all of my code is going to be on a single line. And it's really ugly, like this. You can see so it's a really, really long line. If I want to break up my line to make it more readable, I put dot, dot, dot like there. It changes color to blue. And then I do the same thing over here, like that. And it allows MATLAB to know that these 3 lines are actually part of the same line. They're a continuation of. So like dot, 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 like how you'd use it in real life. Dot, 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 it means like continued. All right, so this is top patch on the top box, on the red box right there. And then here is the definition for one of the side patches on that top box. And you can see I've defined all of the x values here and all of the y values there. and all of the Z values there. And notice it's 3.5 centimeters, 3.5 centimeters, 5.5 centimeters, and 5.5 centimeters. So basically it's 2 low parts and 2 high parts that are being defined in a square on that top box right there. And then the color 2, which is defined as red earlier. So you can see I've defined a bunch of different patches. You have to come up with the definitions for the other patches, and you should be referring to the math that we did, the trigonometry that we did, the different triangles that we defined earlier in order to inform how you write this code. And that will be the real tricky part that you're going to do for the lab. Okay, so basic trig, but it's applied to MATLAB. Remember that we're using the degree version of the sine and cosine features, and remember your SOHCAHTOA. Okay, so sine is opposite and hypotenuse, cosine is adjacent and hypotenuse. Don't worry about the TOA. Okay, so sine and cos. All right, so good luck with all of that, and also pay attention to what's described in the lab manual about applying the if, and else components of the conditional if statements. All right, good luck.